Welcome to video 1.12 on direct variations. Seems to be a complicated name, but it's actually a very simple skill if you're feeling confident on solving equations. And let's get started. This is so true, and I don't know who put that secret out on the internet. I need to find them. So some vocabulary you need to get down. A direct variation is a relationship that can be represented by the function y equals kx. What does that mean? All it is a line that crosses the y-axis on the coordinate plane at 0. There's no y-intercept. So if you have a line and it crosses like that, or even like that, that should be at 0, 0. Whichever line does not have a y-intercept at all, a y-intercept of 0 is a direct variation. That's it. And then k, the coefficient or the slope of the line, is called the constant of variation. So basically the slope of the line is the constant of variation. So example 1, to identify a direct variation. You're going to see problems like this. Does the equation represent a direct variation? If so, identify the constant of variation. So when I solve these for y, I'm going to solve these for y to find out, because remember that formula is y equals kx. We need to put it in that form. We should get no extra things over here, just y equals a coefficient in x. So let's do let's solve for y. And to solve for y, I'm going to divide by 7 on both sides, and I get y equals 2 over 7x. So yes, that is a direct variation because there's nothing else over here. It's just y equals 2 over 7x. So for our next example in part B, we have 3y plus 4x equals 8. And just like I did in part A, I have to try to isolate y, and we've solved literal equations before, so we know how to do it again. We're going to take away 4x from both sides. We get 3y equals, I'm going to put it in the format to have x first, so negative 4x plus 8, but you could also have 8 minus 4x, it's fine. And I'm going to divide by 3 on both sides, and I'm left with y equals negative 4 thirds x plus 8 over 3. You can leave it as a fraction just like that. But it is not a direct variation because of this piece right here. Since we have the plus 8 over 3, it is not a direct variation. So sometimes we're going to have word problems, of course. So example 2, we're going to write our own direct variation equation. Suppose y varies directly with x. Whenever you see that right there, you know it will be a direct variation. You don't have to figure it out. And y equals 35 when x equals 5. What direct variation equation relates x and y? So let's answer this part first. Of what direct variation equation relates x and y? So I know that the formula is y equals kx. What I don't have here is k. So what I need to do is plug in my values for y, 35, and my values for x of 5 to find out what k equals. I'm going to divide by 5, and I get k equals 7. So to write my direct variation equation, I'm going to take that 7 and plug it back in for k here. So I'm left with y equals 7x, and that is my direct variation equation. So when you're not given the coefficient of variation, you have to find it yourself by using x and y values. So now we can answer the second part of what is the value of y when x equals 9. So I'm just going to plug in 9 for x. Y equals 7 times 9. Y equals 63. Get those notes down, bring in any questions you have. So now we have an application question that not only takes into account creating the direct variation, but also graphing it. So this problem says the weight on Mars, y, varies directly with the weight on Earth, x. So the weight of the science instruments on board the Phoenix Mars lander weighs 130 pounds on Earth and 50 pounds on Mars. What is an equation that relates weight in pounds on Earth and on Earth X and weight on Mars Y? Graph the equation. So right here we have Earth, weight on Earth is X, weight on Mars is Y. We're going to do the exact same thing we just did in the last example, where we're going to take our equation of Y equals KX and plug in our X and Y values. So the value of your weight on Mars is 50 pounds. And that is equal to K times the weight on Earth, which is 130. I'm going to divide by 130. And I get K equals, we'll round it to 0.38. So my function is Y equals 0.38x. So I have that, and now I have to graph it. And weight can't go below 0. So I know I just need this graph right here of my X and Y axis. I can make my Y values go up to whatever comes out after we plug in our X's, but my X value is my independent variable, so I know I can control those. So I'm going to go by 50s and just go up to 150, since the max one that I'm measuring in the example is 130. So I'm going to plug in each of these X values in for my Y values. In for my X values here, and then solve for Y. So when I plug in a 0, Y equals 0.38 times 0. It's just going to be 0. We're starting at 0, 0, and that makes sense because direct variations always cross at 0, 0. Now I'm going to plug in 50 for X, and when I multiply 0.38 times 50, I get 19.23. And then I'm going to plug in 100, and when I plug in 100 for X, I get 38. And then I'm going to plug in 150, and when I plug in 150 for X, I get 57. So now I'm going to label my axes, and this is going to go 50, sorry I'm a little squished, 100, and 150. And then this can go up to maybe 60, so we'll go 20, 40, 60. And of course I need to label, but I'm running out of room, so this would be, we'll do it another color so you can see it. I'm sorry this is so sloppy. Weight on Mars, and this will be weight on Earth down here. Okay, so now I'm going to plot my points and connect my line. So we have 0, 0 already done. 50, 19.23, right about there. 100, 38, right about there. And 150, 57, right about there. Connect my lines. That is the direct variation of weight on Earth to weight on Mars. For your hot question, suppose Y varies directly with X. Write a direct variation equation that relates X to Y when Y equals 125 and X equals -5. Go back to example 2 to help you with this one. It's exactly what we did there. And then, just for entertainment, my favorite food joke ever is on the side. Answer your hot question, come with questions tomorrow, and enjoy.